H ratio test. This is another type of convergence. It's called ratio test. This provides the general way to compare the series with geometric series. But it formula the hypothesis in a way which is particularly convenient. So I will define the definition. Let summation an be an infinite series and suppose limit n tends to infinity mod an plus 1 by an equal to r. The series converges if r less than 1. Series diverges if r greater than 1. Series inconclusive. We can't say convergent or divergent in the case of r equal to 1. This is the ratio test. Given series, you take the n plus 1 the term and nth terms ratio. That is a finite. Then you can say that finite value is greater than 1. You can say corresponding infinite series is divergent. That finite value is less than 1, you can say corresponding infinite series is convergent. And in the case of that finite value is 1, you can say inconclusive. You can't say convergent or divergent. Okay. One plus 1 by 2 plus 1 by 3 plus etc. 1 by n. This is the series. So you take an is 1 by n, an plus 1 is 1 by n plus 1. You take the limit an plus 1 by an equal to limit 1 by n plus 1 by 1 by n. That can be written as n into n plus 1. Limit n tends to infinity n into n plus 1. N by n outside we can take 1 by n cancelled. Limit n tends to infinity 1 by 1 plus 1 by n, that is equal to 1. So here in this series 1 plus 1 by 2 plus 1 by 3 plus etc. That means summation 1 by n equal to 1 to infinity. This series limit n tends to infinity an by an plus 1 or an plus 1 by an plus 1 by an is 1. So we can't say the corresponding this series is convergent or divergent. In this case, fail the test. In this case, we say fail the test. In this type of series can be convergent or divergent. So we can say this series is divergent. We already see that. Previous lecture we already see that this series is divergent. Next one of the series, explain summation 1 by n square. So you can take an plus 1 by an, that is n 1 by n plus 1 square by 1 by n square. You take the limit value, limit n square by n plus 1 square equal to limit n square by n square by 1 plus 1 by n square. You can take n square outside. So n square and n square cancel. You got limit 1 by 1 plus 1 by n square. Here this 1 by n square converges to 0. So you got 1. So here also you can't say this series is convergent or divergent. You can say the test is failed in this case. The limit value is 1. Then you can say test is failed in this series. But you already know if n greater than 1, corresponding P series is convergent. So this 1 by n square is convergent. Series 1 by n square is convergent. But above series is divergent. If n less than or equal to 1, P series is divergent. So here you got the ratio will be 1. One of the series is convergent and the other series is divergent. So we can't say the ratio equal to 1, that is convergent or divergent. So that time we will say that the test will be failed in that series. So you can choose another test for finding convergence or divergence in particular series. Okay. I will explain one more problem. Given that the series is 2 power I by I power 8. So here we use the ratio test. So AI equal to 2 power I by I power 8. So AI plus 1 equal to 2 power I plus 1 by I plus 1 power 8. Limit I tends to infinity AI plus 1 by AI, that is equal to limit I tends to infinity 2 power I plus 1 by I plus 1 power 8 divided by 2 power I by I power 8. That is equal to limit I tends to infinity 2 power I plus 1 by I plus 1 power 8 into I power 8 by 2 power I. Okay. The reciprocal we write. Then you can cancel the 2 power I and 2 power I. Here limit I tends to infinity 2 power I into 2 by I plus 1 power 8 into I power 8 by 2 power 8. These 2 power I will be cancelled. You got limit I tends to infinity 2 I power 8 by I plus 1 power 8. Limit I tends to infinity 2 I power 8 by this I will take outside I power 8 1 plus 1 by I power 8. I power 8 I power 8 cancelled. So limit I tends to infinity. These I power 8 and I power 8 cancelled. 2 by 1 plus 1 by I whole power 8. Okay. All of you know that is limit I tends to infinity 2 by 1 plus 1 by I power 8. All of you know 1 by I tends to 0 if I tends to infinity. So this term will be 0 if I tends to infinity. So we can conclude the limit value is 2 by 1. That is equal to 2. This is greater than 1. So given series is convergent. Okay. In this way, you can find any series convergence and divergence. Generally, we used in this